in this example, we're going to take a function that is neither injective nor surjective, and we're going to limit the domain and or the codomain in a way that will make it an injective function and in a way that will make it a surjective function. So the function I'm talking about, well, let's see, we've got a and b, they're just subsets of the real line, real numbers. F maps a into b, and it's defined as f of x equals x squared. So typically I would say f maps r into r, the real numbers into the real numbers, defined as f of x equals x squared. What we want to do is find the largest possible a and b, it'll be an interval for each one, where f is injective or surjective. We're going to do it in two different steps. So notice that this function is not one-to-one. It's not injective because it doesn't pass the horizontal line test. I drew a horizontal line. Could have drawn it a lot of other places. And it crosses the graph twice. So, what though could I do, reducing a or b in some way, to make it an injective graph, a one-to-one graph? Well, the only way I'm going to get it to pass the horizontal line test, well, one way anyways, is use only this much of it. If you take only the right half, then it passes the horizontal line test. It's one-to-one, so f would be a surjection. I'm sorry, an injection. Okay, so it's injective. I'm going to say just set A, the domain, equal to the right half of the x-axis, including 0. Now, didn't have to do it that way. I can think of one other way to do it. Use the left half. This part of it, this left half, will pass the horizontal line test, so that would make it an injection as well. So I'm going to say or a equal, let's see, negative infinity to 0. That's all we have to do to make it an injection, an injective one-to-one function. Now, let's skip that, move on to the next thing. Surjective, or make f a surjection. That means that every element in B has to get mapped to. Notice this, the values of B are considered the values of the function, the height of the function. No negative numbers at all. So if I want it to be surjective or onto, all I need to do is make B restricted to 0 to infinity. Just set B equal to this. Now, every single height, every single positive number, including 0, gets mapped to. That's all we need to do. In one case, we made it an injective function by limiting the domain. We made it a surjective function by limiting the codomain. And before we finish this video, one more definition related to what we're doing. F, which maps A into B, is bijective. You probably remember this. If what? It's bijective if it is both injective and surjective. If it is both injective and surjective. And 1,000 times more likely you're going to hear one-to-one and onto, which means injective and surjective.